Okay, so here is the next question. Right? What does force do fundamentally? Right? Now, let me start with a slightly different question, which I often like to start a class with. So let me ask you, what causes motion? So let's write this down. What causes motion? Right? And I would like you to actually pause the video now and just think through this and maybe talk to your friends and then resume this video, right? So whenever I ask this question, the answer that I get very, very often is that force causes motion. Force causes motion, right? Seems pretty obvious, right? And yet, this is the wrong answer. Must be wondering, what is that? Till now we've been talking about force causing something to move and something to stop, but fundamentally when we say motion, right? Force does not cause motion. In fact, one of the most interesting things in science is that an object which is moving, right, will continue to move. In fact, force is required to change the state of motion. So force does not cause motion. What does force do? Force causes, right, change in state of motion, right? Now you must be wondering, what does it mean? I mean, all this sounds like Greek and Latin to me. So let me explain, right? If you take an object, so let's say there's a floor and you have a chair here, right? And let's say you push the chair, give it a push and leave it. What will happen? It will drag for some time, then it will slow and stop, right? So you'll say, no, but see, because when I applied force, it started moving. When I stopped applying force, it came to a stop. Right? So you'll say, no, force, it does require force to move. My answer is no. Why is that? Here the surface was a normal, like in a normal floor, it's a rough surface. Now what if I had kept this on, let us say, an ice-like surface, very smooth? Instead of the chair stopping here, the chair may have gone much further. Now you can kind of visualize that if the surface became smoother and smoother, it would go farther and farther. And in an ideal scenario, if the friction was zero, the surface was absolutely smooth, this chair would keep moving forever. It would not require a force to keep it moving. Right? Another example, let's say you're playing a game called Carrom board, right? As kids, you might have played that. Now, every time you put some powder on the board, the coins would move further, would move much more easily, right? Same thing there, when the friction goes down, the coin will move farther. Right? So this is one thing which I'm going to tell you, which is that an object will continue in its state of motion. It will continue to move with the same speed in the same direction, right? And that is what I'm calling the state of motion, right? And if I need to change that, change what? If I need to change the state of motion, which means if I need to change the object from moving in a straight line at a constant speed, if I want to change anything there, then I require force. So what can I change? First thing, I might want to change the speed, right? Change the speed. I might want to increase the speed. So let us say let's say your friend is driving a bicycle and you're waiting for him or her to come, and when he or she comes, you kind of you put your hand and stop the bike so that you can chat with your friend. So what are you doing? Your friend, when he or she is coming, he or she is in a state of motion. By applying a force, you are slowing it down and you're changing it. So changing the speed, right? Now let's say you're really you're kind of upset with your friend, or you wanted to kind of give him a surprise. When the friend comes, you give a force from the side. What will happen? It will change direction, right? Or another example is, let us say if you, let's say there is a planet here, which is going around. Sorry, there's a planet here. I drew it badly, right? There's a planet here which is going around the sun, right? What is happening? The sun is pulling it. As a result, it is not able to go straight, right? It keeps going round and round, right? Here also there's one example where there is a force of gravity, which is changing the state of motion. It is changing the direction. So it can change the speed, or it can change a force can change the direction, or it can change both. Right? So these are, all the examples, I would like you to now start thinking about it. So look around you, right? Any example that you take. So you could take the example of, let's say, a cricket ground, where every time a batsman kind of hits the ball, or a football game, or let's say a rocket is fired. Everywhere, right? If you are seeing an object not moving at a constant speed in the same direction. There has to be a force, and you should think about and figure out, where is that force coming from? Okay. Now, one other thing, right? In some cases, you'll find, let us say now you're sitting, let's say, on a couch or a bean bag. Let's say this was a kind of bean bag, right? And you just came home, you're kind of really tired and just go and plonk yourself. So you come here and you just sit down. What will happen? Now the bean bag will have a different shape, right? It'll get crushed. So what did you do? Well, you applied a force and it caused the bean bag to change its shape, right? And there are a lot of examples like that, right? If you say, so let's say you are, kneading dough, or let's say there are some spring-based exercise equipment you can take, and you can turn something, you can push it inside, right? So there are a lot of those kind of things, where you are applying a force, and force is causing the change in shape of an object, right? So this is our conclusion that what force does is it does not cause motion. No, force does not cause motion. Force causes a change in state of motion, which means it can either change the speed, or it can change the direction, or it can change the shape of an object, right? If there is and by the way, one other thing, right, which you should know, we are talking, when you say a force, we're talking about the total force on an object, total force, right? So as an example, right now, if I'm standing here steady, what is my state of motion? I'm at rest, I'm not moving, right? Is there a force on me? Yes, there are, but there is not just one force, there are two forces. One is, there's a force of gravity, right? So let's say if this is me, this is myself, right? Now, there are two forces. One is there is a pull of gravity down, right? And there is a push upwards from the surface, from the floor I'm standing on, right? And this force, right? They both cancel each other. So the net total force here is 0. And that is why my state of motion is not changing. I'm at rest. Okay, so we have to look at the total forces acting on a body, and like we discussed in one of our previous videos, when there are multiple forces, we have to see if they are in the same direction or opposite direction. Same direction, we add them up. Opposite direction, we subtract them. Okay, of course, you could also argue about what if they are on different directions. That is something we're not going to study right now. So we are going to go with these simple cases. Okay, thanks very much.